Okay, so I'm back, and we're talking about the current in a series circuit. So let's go back to the lab, the Microsoft Excel lab, and scroll up until you come to that green and purple box again. And so that is going, you'll notice, what does it say in the series circuit? It says in a series circuit, the total resistance was the sum of the resistors. What's next to it? It says that the current in a series circuit is the same everywhere. So the current through resistor 1 is the same as the current through resistor number 2. And then what does it say next to it? It says that the total voltage is equal to the sum of the individual voltages. And that's what we showed, that 3 plus 6 makes 9. Okay, so I'll let you do it if you want to. You can pause the tape and then continue it, but you might want to take that ammeter and maybe put it in between the two resistors, or take the ammeter out and put it on the other side of the circuit and see what happens. And you're going to find that no matter where you put that ammeter, it always gives you the same reading, because the current is the same everywhere in a series circuit. Okay, now we want to calculate what should be the voltage and what should be the current in a series circuit. Okay, now in order to do this, it's really better if you would now go to, you almost need a third computer for this, but if you go to your notes. So go back to your notes, and I'm going to open it up on my computer here. And so if we go back to the PowerPoints, and then we're going to go down to lesson number 21 and open that one up. Okay, and then I'm going to go down to, now I think that this is correct, but I'm going down to slide number 23. So on slide number 23, that's a picture of what is the total resistance in a series and parallel circuit, what is the current like, and what is the voltage like in the series and parallel circuit. So we're going to be using this. And then if you go down to slide number 24, that shows you how to solve a 2 resistor series circuit and a 2 resistor parallel circuit. So which circuit have we just built? We've built the series circuit, so that's that purple one in the first column. And it says, number 1, first find the total resistance. Okay, so on your scratch piece of paper, we already did that. So our 2 resistors were 10 and 20. So the total resistance was 30. So you might want to write this down on a scratch piece of paper. Step 1, total resistance was 30. Okay, step number 2. It says, next use Ohm's law to find the total current. So we're going to write down Ohm's law. V equals IR. Okay, now V is the 9 volts that's coming out of the battery. Okay, I, we don't know. So we're just going to write 9 equals I, but we do know what the R is. So the R is my total total resistance. 10 plus 20 makes 30. Okay, solve that for the letter I. So go ahead and do that. Okay, and you get 0.3, which is exactly what the current meter showed on the FET simulation. So now we know current 1 and we know current number 2, and so that's the calculated current 1 and current 2. So now you can fill in those boxes on your lab. Okay, now let's go back to the notes, and in that purple column, number 3, it says, lastly, plug the currents that you've just gotten into Ohm's law to find the two voltages. So we're going to write down V equals IR, but this time we're going to put subscripts. Voltage across resistor 1 has to equal current 1 times resistor 1. Okay, now do we know voltage 1? No, we don't know it yet. But do we know current 1? Yes, that was 0.3. Do we know resistor 1? Yes, that was 10. So 0.3 times 10 is 3. So that's voltage number 1. Okay, now you do voltage 2. So voltage 2 would be current 2, which is still 0.3 because the current is the same everywhere. Resistor number 2 was 20 ohms, so multiply them together and you get 6, which is what we measured the voltage to be. Or did we measure the voltage? Yeah, we did. Okay, so now let's go back to the lab, and now you should have all of the boxes filled in. Okay, for under part 4 you should have all the boxes filled in except for the measured resistance of the resistors. So that column should be blank, but now you should have all those other boxes filled in. So now we're ready to do resistors in parallel, and we're going to do that in the next video.